this conference has evolved over the years to be the premier bridge inspection conference and tunnel inspection now. And I'd really like to thank the organizing committee for the invitation to speak here. It's quite an event. As Debbie mentioned, I'm the state bridge engineer for the state of Idaho, and I was talking with somebody today, and he introduced me to a fellow friend, and he said, Matt's the Bruce Johnson of Idaho. And I said, wait a minute. Oh, well, no, that sounds pretty good. I'll take that. Bruce Johnson is a state bridge engineer from Oregon, and I have a lot of respect for Bruce. I understand he's not here, but I thought I'll take that. That's pretty good. In Idaho, we spend about $80 million a year on bridges, so about 15 to 20 million on bridge preservation and about 65 million roughly on bridge restoration or bridge replacements. And it's quite a challenge to address all our bridge needs with that amount of money, but we're doing our best. And along with those duties, I'm also the chairman of the AASHTO SCOBS T-18 Technical Committee on Bridge Management, Evaluation, and Rehabilitation. What I'd like to talk to today in my presentation is about proposed changes that we have on the horizon for the Manual for Bridge Evaluation and also the Manual for Bridge Element Inspection. And then I'd like to change gears a little bit, but talk about the FAST Act legal emergency vehicles and bridge posting, which is quite a challenge for all the states right now. But I bounced this term around T-18, and you know, maybe a lot of you don't really follow what that means, but T-18 is part of AASHTO SCOBS, and you might say, what's SCOBS? That doesn't sound very good, but that's the subcommittee on bridges and structures that AASHTO has created. It's populated with the state bridge engineers from all 50 states, and FHWA is involved. But there's 20 technical committees on subcommittee on bridges and structures, and T-18 is one of them. There's also a T-9, which is a technical committee for bridge preservation, and, for example, T-14, which is steel bridges. T-18's responsibilities primarily revolve around the maintaining and updating the AASHTO Manual for Bridge Evaluation, the MBE, and we also maintain and update the AASHTO Manual for Bridge Element Inspection. And I know you guys are familiar with that one. I'm always checking to see how many people have copies of the MBE, but I know you got copies of the Manual for Bridge Element Inspection. So for this year, we've got 4 proposed changes or ballot items for 2017, and they kind of relate to a wide gamut. One of them's on bridge management. One of them addresses some clarifications we've got for load rating for bridges without plans. We've also got a ballot item that talks about underwater inspection and acoustical imaging. And also we've got a ballot item that makes some clarifications to Section 7, fatigue evaluation of steel bridges. Also on the docket are one proposed change for the Manual for Bridge Element Inspection. So the first one, it's a pretty big one. It's a complete revision of Section 3 of the Manual for Bridge Evaluation, and that covers bridge management systems. We've kind of taken the posture of we wanted a kind of a primer, Section 3, to represent kind of an introductory primer of what a bridge management system is and what are the components and what's the purpose. And we think this is of value to the states to kind of give them a brief introduction before they get into all the meat and potatoes of a bridge management system. We've, pretty much split it up. This is a table of contents, if you can see that. It's split up into objectives, and it's the basics of the components of a bridge management system, how we integrate all that information, and then finally how we prioritize projects and how we're going to spend money. It's always good to state what the objectives of a bridge management system is, and you know, we use a bridge management system in Idaho. We've been very successful using bridge performance measures in order to express the needs that we have for our bridges. And we've got our share of money from the paving guys to address those bridge needs. But really, we use it as a tool, and you can't rely on a bridge management system as your only decision maker. You've got to have engineers and bridge inspectors in the process as well. We really emphasize that in this particular section. The three main components, of course, of this whole chapter are data and element level aspects of a bridge management system. You've got to have a way to quantify and capture all that information. Second section is the data integration and how we use risk assessment, agency rules, how we make decisions on cost and benefit. And then finally, there's a prioritization section in this chapter that describes how we use multi-objective optimization. We've really got a lot of mileage out of that term with management. They really like that one for some reason. But the other thing about this section that's really neat, I think, is that it mirrors the way AASHTO BRM, the latest version of AASHTO-ware BRM, is organized. And there's a great correlation between the way they explain the way a bridge management system works and the way we have described it in our section 3. And they kind of like to think of it, AASHTO-ware, as a pyramid, with the base of the pyramid being all of our data, all the inspection data, all the work candidates or the items that you as inspectors are getting and noting in your inspection reports in the field. And then the middle section of the pyramid is the way where we make all our agency rules and define how we're making decisions for the model. And then ultimately we've got the project optimization. Right now in Idaho, we bought some service units and we're working with Bentley, who is the prime contractor for AASHTO-ware. And we're getting the training on how to establish our agency rules, how to use this program. It's got a lot of bells and whistles and neat dashboards that we can use to talk with our legislature and our management about what our bridge needs are and how we're doing. Okay, second ballot item that we're working on is kind of clarification of how we have described how you would load rate or post bridges where you don't have, concrete bridges where you don't have plans. And in the manual for bridge evaluation, we had 3 different areas where we talked about this issue. And the effort, or the purpose of this ballot item, is to condense that all into one place and kind of eliminate a lot of that duplication and questions that were coming up. The third item I think you might be interested in is through a lot of research and a lot of the practitioners out in the inspection world, we have come up with this concept of highlighting acoustical imaging as a underwater inspection technique that could be used where diver safety is an issue. A lot of times we're all faced with rigid inspection cycles for our underwater inspection, and sometimes we're required to go out and do that underwater inspection when conditions aren't ideal for divers. And On T-18, we have many states that are along the Mississippi and Missouri rivers, and we have understood that they have worked collaboratively with FHWA to utilize this acoustical imaging. In Idaho, we've done quite a bit of work with acoustical imaging, and from our point of view, we think this really satisfies the majority of our questions that we have about underwater inspection, particularly when it comes to scour and what the channel bottom is doing and debris buildup. We know it's not as good as a hands-on inspection by a diver underwater, but a lot of our bridges are in relatively new condition, and we've done level 1 and level 2 inspections. And we think in these cases where the water level is high or where it's not easy to get a diver in the water, that we ought to be able to utilize this acoustical imaging. And coincidentally, FHWA had done a pooled fund study 3 or 4 years ago, and we just got word that they're about ready to publish the draft research report from that pooled fund study. And we believe that document will support our efforts to change our manual for bridge evaluation and work with the feds in this particular area. As I say, we've used this method in Idaho. We think it gives us good results. It gives us a good picture of what's happening underneath the water without actually having to get a diver in the water. Again, if you've got a very old substructure and it's got a lot of deterioration or spalling or other issues, maybe acoustical imaging by itself is not the best approach. But we believe this is a really valid, useful approach if you've done previous underwater level 1 and level 2 inspections, level 3 inspections. So it's kind of a chicken and the egg. We're changing the MBE, and we're working with FHWA to work this into their mix. And really what we are proposing to the states is they document what kind of underwater procedure they're doing and why they would use acoustical imaging over the traditional methods. And I think, at least in the preliminary conversations we've had, that if you document that and you've got a rational approach, we think this is something that's going to be acceptable to FHWA. The last ballot item deals with fatigue evaluation of steel bridges, and it's mainly an update of this section in regards to some changes that we made to the LRFD in regards to load factors and stress ranges. Another big item that affects you all directly is a ballot item that we kind of came late to the game, and we're working with FHWA to move forward on this ballot item, but we're not going to vote on this particular one, but we are trying to work with FHWA. We want to get this information out to all the states, and it revolves around the idea of, for fracture critical members, the designation of internal redundancy. And internal redundancy is applicable when you've got build-up, riveted, plate girder type members. And there's a lot of research going on in this area, and they've demonstrated that if you've got a built-up plate girder and you fracture one of the plates in that built-up member or an angle, that you haven't necessarily lost the whole bridge. And so in this way, the research has come up with the term internal redundancy. And they've established a procedure through this research whereby we could adjust the inspection frequency. And in this information that we're getting out to all the states, we've got a little example. And this particular example is a 75-foot simple span, 2 girder built-up plate girder riveted that we're considering in a faulted and unfaulted state. And you know, there's a lot of bullet points on this thing. I don't expect you to read them all, but basically what we're doing is assuming that one of the plates fractures, and then we're checking a strength case to make sure the bridge doesn't collapse and that it can handle the loads. The load we're putting on that is an HL93 live load. And so if it makes the strength case and is able to stand up, we check it for remaining fatigue life. And according to the research, and FHWA is aware of this research and they've supported this research all along, you determine a remaining fatigue life, and then they have a method where you can determine your inspection frequency. And in this particular example, they were able to extend the inspection frequency up to 8 years. So that's a pretty big change from 2 years to 8 years. I imagine you're kind of going, what? How does that work? But with this method, we don't intend to have to change CFR or any of the definitions that's required in there. But when we designate it that it has internal redundancy, and we've went through this policy and procedure and this research that's been done, it's no longer fracture critical. And by that method, we don't have to apply the definitions of the CFR, and we're able to establish a longer, potentially a longer inspection frequency. So this one's pretty big, potentially could be a game changer for you all. And we're currently talking with FHWA and Shay and Joey Hartman and the whole gang, because this one is maybe viewed as somewhat controversial. And lastly, the one item that we have for the manual for bridge element inspection is one that's been out there for a while. Currently, for bridges on the National Highway System, we're all collecting element level inspection data. But we're not required to collect defect quantities. But some states do, and Idaho does, and we use that information for our maintenance management systems. And one aspect of the element level inspection is that we always record the predominant defect, or predominant defect that defines the condition state. And with this ballot item, we're giving the option to collect quantities of defects that are overlapping. Right now, the way the manual for bridge element inspection, the way it's written is you collect the predominant defect, the quantity of the predominant defect. And with this proposed ballot item, we're allowing states, if they'd like to, it's not mandatory, if you'd like to, you can collect this overlapping defect information and utilize it for your maintenance management systems. And in this example, I know it's a little hard to read, but the upper box kind of gives you a sense of how we collect the data now. In this example, you've got a predominant defect of a 10 linear feet of spall on a particular girder. And so that rolls up into the condition state 3 element, or quantity of condition state 3 of that element. In the future, and BRM is already set up to do this, you can collect the defect information and quantity for overlapping defects. And in this particular spall, there's also exposed rebar. So if you're trying to tell your maintenance folks to go out and do a patch on this thing in order that you protect that rebar, it also gives them a sense of how much rebar is exposed. But as you can see from the table, these don't add, sum up. You're still only reporting the predominant defect. Okay, I'd like to switch gears now from ballot items and talk a little bit about FAST Act vehicles and other vehicles on the horizon. And these FAST Act vehicles are, as Shay mentioned, somewhat controversial because the states are required at the end of March to submit their plans on how they're going to rate all their bridges on their interstates and potentially post those bridges for this emergency vehicle. But in the FAST Act, there was a lot of vehicles. That emergency vehicle was only one of them. There's also the heavy-duty tow and recovery vehicles, and individual states were called out for specialized vehicles and milk products. The whole gamut is out there on the horizon. And if you're in the load rating world, you're pulling your hair out right now. I don't have much to add about the heavy-duty tow and recovery vehicles. I'm glad FHWA is working through that, and they haven't really offered any technical guidance to the states as yet on it, and we'll wait to hear from where you're going with that. The other big one, though, is this emergency vehicle. And these emergency vehicles are single-unit trucks, and they can have single axles or tandems, 3-axle trucks. But they definitely do not follow federal Formula B, and most states' weight limit statutes follow federal Formula B. These don't. And in Idaho, these vehicles are not permitted off the interstate. You need a permit to use these vehicles, but on the interstate, they're legal. So we've done some screening of all of our bridges and for all the interstates in Idaho. And these gives you an idea of what they look like. You know, they're not that oddball. You may have seen these out there. The key aspect of these is I believe that they're allowed to carry water, and that's what's making them heavy. But as I said, in Idaho, we've screened our bridges. We have about 22 bridges on our interstate system that would require posting. We're not completely done with all of our load rating, but we have about 22 we've got so far on our interstates that would require posting, and another 44 bridges within the 1-mile radius of the interchanges that would require posting. And so we're trying to figure out how we're going to operationally make this work, because you don't want to put a posting sign up on a bridge on the interstate and then have that vehicle get that far and then have to back up or turn around, or, you know, so we're trying to think operationally how we would post at the nearest interchange. And also that might be at the state line, you know, or we might come to our neighboring states and say, we'd like to put a posting at the closest interchange to the border to let these trucks that are going, they aren't originating in Idaho, they're going to be coming from another state going somewhere else. So we've been talking with our division bridge engineer and thinking about how we're going to apply this, but it's a question that every state is facing. One aspect of these trucks, anecdotally, I heard 31 states have statutes that say if it's legal on the interstate, it's got to go anywhere in the state. So the challenge for those states that have those statutes is they've got to load rate all of their bridges for these emergency vehicles, and that's a huge cost, and it's a huge time constraint. When we load rate them, some of them come up that we got to post them, and FHWA has worked with MUTCD, and they've proposed that this is the sign that we would use to post out on the interstate. And I know in Oregon, you've got the SHVs, and you've got posting signs for those, and you've got your regular posting signs, and now potentially you've got another posting sign, and you can kind of see what the confusion's going to be if we've got all these signs out there. So it's a big issue, and T-18's trying to work with all the states and FHWA to try to come to a conclusion on how best to do this. The other thing I'd like to talk about is not in the FAST Act, but it's an issue facing many states that have big agricultural industries, and it's these implements of animal husbandry. And you can see from the picture, 40, 50 years ago, the tractors, the old John Deere tractors, weren't that big. They were tri-axle or tricycle type tractors, and the whole farming industry's changed. We got these huge vehicles with trailers with fertilizer and all sorts of things out there now. And they're not just traveling the farm fields, they're traveling on our local roads and sometimes on our state highways. There's very hard to define. There's tons of different configurations that are out there, but they're, big axle weights. A lot of these would not be defined as being legal. And there was a pooled fund study out there organized by Iowa and Illinois, Kansas, all the Midwestern states, to their legislatures have enacted statutes that have made these kinds of vehicles legal. We haven't got that far in Idaho. Our legislature has not made these legal, and so they would need a permit to travel on our state highways or local highways. But along with that pooled fund study, there's also been an NCHRP study that's been initiated, and it's underway. We've got some T-18 representation on that NCHRP panel. It's going, it's underway, and results are expected, I think, in 17 or 18. In conclusion, I just would like to stress that we're looking for ways to improve the inspection and evaluation manuals and manual for bridge element inspection. That's kind of our mission on T-18, and we accept any kind of input. We'd like to hear from you folks in any way we can and try to make this better and more useful. Thank you.